Today we're going to talk about independent and dependent events in probability. And we're going to talk about how to find the probability when something's independent and when the probability when something is dependent. So first we're going to start with a quick warm-up question. So if we go back to what we know about simple probability, if I have a bag with 3 blue marbles and 2 red marbles in it, so you can kind of see over here. So right now I want you guys to just tell me what would be the probability of getting a blue marble. So you're going to type that on the screen. Hopefully you guys were able to see that the probability in blue would be 3/5. Because I have 3 blue and 2 red, so I have 3 out of 5 that are blue. So my next question to you, if I put the marble back in and pull a marble without looking, is the probability of picking a blue marble different? So like let's say that I pick out a blue marble and I put the blue marble back in the bag. Have I changed the probability of getting a blue marble the second time? What do you think? Yes or no? So I hope that you guys realize that the answer there should have been no. The probability is not different, okay? Even though I got a blue the first time, because all the marbles are still the same colors and the same number of colors in the bag, my probability would not change. Now, what about if the probability isn't affected of drawing a blue marble the second time if I do not replace the first marble I draw? So if I sit here and I pick a blue marble the first time, so now I have this blue marble and I do not replace it. Have I now affected the probability of choosing a blue the second time? So I hope that you recognize that yes, now it was affected. Okay, so this is going to be some examples of independent and dependent probability. So when I look at this, independent probability is going to be when the outcome of the first event is not affected by the second event. So that first question you answered, the probability of blue was not changed because I put something back in. So, for example, the teacher calls on a student by drawing a stick. After the student has answered the question, their name goes back in the cup with the rest of the students. So everyone's probability stays the same because the name goes back in. So the denominator would stay the same with each pick. Some keywords to recognize independent probability is returned, replaced, put back. However, dependent probability is when the results of one event affect the results of a second event. So for example, when I would pick out a stick out of all the popsicle sticks out, and after a student answers the question, I keep their name out of the cup till everyone's name has been called. That's what I normally do in class. Every time, your probability changes because the denominator is decreasing after each pick. So some keywords are keep it, do not return. So this is some keywords with independent versus dependent probability. So looking at this, I'm going to quickly go through some examples of what independent versus dependent is. So if I look here, if I have a jar that contains 6 blue, 3 red, 5 green, and 2 yellow candies, once a candy is drawn, it is not replaced. So if it is not replaced, then that would mean that it's going to be dependent probability because the second probability is going to be affected by the first one, because once I don't replace it, the total number is going to drop, so my probability changes. So look over here, if I have the same exact ones, but this time after I pick one out, it says it's drawn, it's returned to the jar. So if I pick out a blue one, but then I put the blue one back, or I pick out a green one, and then I put it back, and then I get a blue one, well, my probability of those two events would be independent. Okay, two more quick examples of going through what independent versus dependent is. So if I have a card is drawn from a deck of 8 cards with A, B, C, D, E, F, G, H. So a card is replaced and a second card is drawn. So I want to know what is the probability of getting B and then F. So if I have 8 cards, my probability would first be 1 out of 8 of getting a B. Since I put the card back, getting an F is 1 out of 8. It was not affected by what I got the first time. So since they didn't affect each other, that would be considered independent probability. Now in this last example, I have the same cards, but this time it is not replaced. So if I want to know what's the probability of getting a B and then an F, well, at first my probability of getting B is 1 out of 8. But because I did not replace the card, I now only have 7 cards left because I keep the B. So my B card is gone. So because of that, my probability of getting an F is no longer 1 out of 8. My probability of getting an F is 1 out of 7. So that would be considered a dependent event. Let's try to see what that means in terms of calculating the probability. So when I want to solve for independent or dependent probability, I want to multiply the simple probability of each pick together. So in my example, that was a dependent probability from the previous page, I want to know what happens when I want to find the probability of getting 2 greens when a candy is not replaced. So if I look at my first one, I would have 5/16 is my probability of getting a green the first time. I have 5 green and 16 total marbles, so my probability would be 5/16. However, it says I now am going to draw a candy and not replace it. So once I don't replace that candy, I no longer have 5 green ones. I now have 4 green ones. And my total is no longer going to be 16. I now only have 15 marbles. So I have a 4 out of 15 chance the second time. That's why that's considered a dependent probability, because they are going to change and affect how the two probabilities. So I would go through and I would now multiply my two probabilities together. So if I want to do this, I'm going to look at, I'm going to cross cancel. This 5 becomes a 1 and this 15 becomes a 3. Cross canceling along the other diagonal, this 4 becomes a 1 and this 16 becomes a 4. You don't have to cross cancel, it just saves you some work in the end. So when I look at this, 1 times 1 is 1, 4 times 3 is 12. Another mistake there, but I'm going to try not to make any mistakes like the last video. So I'd get my probability of getting 2 greens as 1/12. So again, I found the event of getting a green the first time, and I multiplied it by the probability of getting green the second time, and that would tell me the probability of both events together. Okay, let's try another one then. Let's look at the independent probability with those same marbles. So this time, when I'm doing this, I am returning the candy to the jar. So it is an independent probability experience here. So at first, getting a green would be 5 out of 16 for my probability because I have 5 green marbles and 16 total marbles. Now the second time, since I put it back, I still have 16 candies in the jar. So if I want to know what's the probability of getting a green one, 5/16, then a blue one, now I need to find what's my probability of getting blue. So my probability of getting blue would be 6 out of 16. It's still 6 out of 16 because I did not change the total number of candies in the jar. Now, before I do any of this multiplication, I'm going to take my 6/16. I'm going to simplify that down to 3/8 to start, just to make my numbers smaller to multiply with. So now I'm going to go through and I'm going to multiply these two probabilities together to get the probability of both events together. So when I go through that and do that, I would get 15 over 128. So that would be the probability of getting both of those together. Let's just do a couple more practice problems with these. I just have 3 more quick examples for you. So now I want to be looking at a letter tile is selected and the spinner is spun. What I get on the tiles has nothing to do with what will happen on the spinner. So those are going to be independent events. The one does not affect the other. So I want to know what's the probability that both will be a vowel. So I'm going to have to look at these separately. I can't just count up how many I have I have 4 tiles and I have 3 sections of the spinner, so I have 7 things in total. That's not how this works. I have to find the probability of the tiles and multiply them by the tiles or the probability of the spinner. So when I start the vowel, I have 2/4 out of my tiles are vowels. However, I'm going to simplify that down to 1/2 just to make my numbers smaller and easier to work with. So I have 1/2 for my probability of getting a vowel in my tiles. I'm going to multiply that by the probability of getting a vowel on my spinner, which is 1/3. No need to simplify there. No need to cross cancel now because everything is super small. So when I go through and do this, my probability of getting both of them of being a vowel would be 1/6. Again, I have to calculate the two probabilities separately. Okay, my last one on this slide is if I have a number cube and a spinner. I want to know the probability of not spinning blue and then rolling a 3 or a 4. So when I look at this on here, again, I need to remember these are independent because what happens on the dice has nothing to do with the spinner. So my first step is what's the probability of not spinning blue? So not blue would be 1, 2, 3, 4 out of 5 different choices. So I have a 4/5 chance of getting not blue. Then I want to multiply that by the probability of rolling a 3 or a 4. Well, I have two ways to get a 3 out of 4 out of 6 total sides. However, again, I want to simplify this down. So I'm going to multiply that by 1/3. When I go through and I do my multiplication, I would get a probability of 4/15. So I have a 4 out of 15 chance of both of those two events happening together. Okay, this one I'm going to have you guys solve. So if we look through this and there are 4 oranges, 7 bananas, and 5 apples in a fruit basket, Ignacio selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. We're going to, even though the problem doesn't specify it, they do not put the fruit back. It says Ignacio takes his fruit, so then the probability is changed. So this is a dependent event. When Terrence goes to select his fruit, Ignacio's fruit is no longer part of it. So find the probability that they both randomly got an apple. So set up that probability. Again, you might want to grab a sheet of paper if you need to, and go ahead and calculate that probability. So what I have here is when we first start, again, there's 16 total pieces of fruit if you were to total this up. So when Ignacio goes to pick, there is a 5 out of 16 chance that he would get a apple. But once that apple has been chosen, there are no longer 5 apples. There are now 4 apples left. So when Terrence goes to pick an apple, there is only a 4 out of now 15 chance because, again, 2 of those apples have been taken out, or one of those apples have been taken out, so now I only have 15 apples left. So when I multiply those two together, I could do my cross canceling and everything like that. However, I remember like 2 slides back, I already solved what this probability was when I multiplied them together. And I do get a probability of 1/12 once I go through and I do my math work and I simplify this down. Today, you're going to be doing some work with figuring out independent and dependent events on IXL. And then you guys are going to be doing a quick Google slide where you're going to calculate 10 problems like this. Let me know if you have any questions.